Back in Unit 2, when we studied radical functions, we also talked about how to graph radical equations by graphing. And this applies to any equation. Any equation can be solved by graphing if you graph both sides of the equation and find the x values where they intersect each other. That's it. So if I said this, like here, I'm going to give you something. I'm going to give you this. And you're probably looking at this going, what is this? And I'm going to say, okay, I want you to solve this equation by graphing, and I'm going to give you this. I'm going to give you the graph of each side. So here's what e to the x looks like. And we're actually going to study this later on. And here's what x or y equals 1 looks like, right? We all know that one. Okay. What's the solution? What's the solution? Like, you don't even know what this is yet. What did I say to look for? Where do you find the solution on the graph?
Is it not with the oh my God.
I just finished telling you. Did you say polygon? On the graph. Where? Yes. So what's the answer?
X equals 0.
Thank you. I heard 1. So x equals 0. That's it. Okay. It does not matter. It does not matter what is on either side. It doesn't matter. Okay. If I tell you the equation and if I give you the graph of each side, you solve it by just finding where they intersect and reading the x values. So here, we're asked to solve the equation cos theta equals 0. We know how to solve that algebraically. What is theta? What are the possible measures of theta?
Something divided by 0.
Something divided by 0.
It's on the one graph, 1 to 4. It's on the circle. Angle over.
Radians, please. Pi over 2. Anything else?
2 pi. 3 pi over 4.
You can stop sharing.
5 over 3. Oh, it's on the 4 pi.
Ellie? Yes.
Right. Right.
Okay, because it's a unit circle value. So we find at what angles is the x coordinate 0? And it's at pi over 2 and 3 pi over 2. What if we solve this graphically? To solve it graphically, okay, split each side. So we need to graph y equals cos theta, because we're going to need to toss a y in front of it, and y equals 0. Right? Because the equation is cos theta equals 0. Well, cos theta, we should be pretty comfortable graphing now. How would we graph cos theta?
Start at 1, sir.
So where, where?
1 y equals 1.
Y equals 1, okay.
Start there, go to 0. X for x equals 0. Oh, x equals 1, y equals 0. Y equals 0. Then, y equals 0, x equals 0. Yeah,
Maybe we should fill in some notches first.
yeah. 4 kids.
4 notches?
Yeah.
What's the value of the 4th notch? What's the value of the first notch? Pi over 2, good. Because you do this divide 4, right? Do I want to put any other notch on the y-axis?
-1.
-1.
0.
So here, and then down. What? Down. Arrows or not?
Arrows going down.
Does anybody want to argue that by looking? No, because we're only asked to graph over this interval.
No arrows.
So it starts here and it stops here. Okay? Where's the graph of what? So we graph this here. The graph of y equals 0 is just the horizontal line. Where would I draw that horizontal line?
Y. Oh, yeah.
1.
No 0. Y.
It's the same as the x-axis, isn't it? So here's the graph of the left side of the equation. Here's the graph of the right side of the equation. Where do I find the solutions?
Where they intersect.
And what are the x values where they intersect? Pi over 2 and 3 pi over 2, which matches up with how we did it algebraically. So that's just proving one proves the other. Like I can prove the algebra works by doing graphing. I can prove the graphing works by doing the algebra first. So just remember that, because a lot of times they like to throw a question like this on the exam. Okay? Where you have to find a point of intersection. So a question like this. Here the graph's given for you. You're told f of x is this, and g of x is this. If we made f of x equal to g of x, what are the solutions that you can see for x? What are the solutions? Where are they, first of all? They're here and here. And it's going to be decimal numbers, isn't it? This looks like it would be around
1.2.
1.2. So x is approximately 1.2, or it could also be 4.6, 4.7. That's it. That's all you have to do. Okay? It was just like when we graphed the radical equations and the horizontal lines in Unit 2 and we found where they intersect. Okay? Okay. Final thing. How can we use trig equations or trig functions, specifically sinusoidal ones, sine and cos, to solve some actual problems? Well, we can take a whole bunch of situations that involve some type of cycle, and we can convert it to a trigonometric function, which allows us to answer questions about it. So anything that follows a cyclic pattern, okay? So for example, a Ferris wheel. If you were to graph, don't write this down just yet. Or actually you can do this because we want to convert it to a graph. So we're going to do this first. And this is going to be the height of our Ferris wheel that a person's at. And this is going to be the time. Okay? So without actually looking at the numbers just yet, we can visualize what the graph would look like. Let's say a person gets on at the bottom. Okay? One would assume that because it's kind of hard to get on the top car if you're on the ground. So where on here would I put a starting point for the person? Here? Yeah? So that means that the Ferris wheel is dragging along the ground? Yeah, you got to go up a little bit. Because otherwise, the Ferris wheel is just going to kind of roll away down the street. Okay. So time starts. You're on. You're excited. You're starting to go up. Right? So you go like that. And then you reach the top. Question? No, don't write this down because I see you guys. I told you. What part of don't write this didn't you understand? And now you roll your eyes at me. Okay? Unbelievable. So we get up to the height, we start coming back down, right? So it's going to look like that? Oh, why not? It goes like this. Oh, it doesn't go back in time. So yeah, it's going to go like this, and then you're going to get on the bottom, and then it's going to go like this, and depending on how far you ride. Okay? So, and let's say that you ride it indefinitely. I put an arrow here to say that it keeps going. Okay? Do I put an arrow here?
No.
Why not? No, this is the starting point. You can't go back in time. You can't go negative time. Okay, so it's going to look like that. But we need specific values. I want to know exactly where this is. I want to know exactly where this is. I want to know exactly where halfway is. And I want to know the length of time I should write down. So this is where we got to go to the question. So Megan gets on a Ferris wheel. It's got a diameter of 30. She gets on 3 meters from the ground, completes a rotation in 60 seconds. Okay? We want to sketch a graph of at least one period of this function. We all agree that she starts a little bit above the ground. According to the question, what value is this? 3. We've learned that with sinusoidal cycles, to complete one cycle, we do 4 notches. Right? What's that? Yes. Okay. What value is this? 60, right? Because it takes, it completes one cycle in 60 seconds and then the cycle starts over again. Okay, but remember, so it's going to start here, it's going to go up to a certain peak, and it's going to come back down and end up here after 60 seconds, right? Question is, what's the height? 30, 33. Because the diameter is 30, and if it's 3 above the ground, we have to go 30 above. Well, remember, to accurately sketch a graph, I need the midline too, don't I? What would the middle value be? How would you find that? Yeah, 33 plus 3, divide 2. And we get 18. Now we've got everything we need. So we know, we start here. After 1/4 of the cycle, we're up at the midline. After half the cycle, we're up at the top. After 3/4 of the cycle, we're back to the midline. And then at the end of the cycle, we're back to the minimum. And we would continue on to the right if we continue to round. So that is the answer to A. We've sketched the graph of the situation. Okay? And remember to label too. Instead of X and Y, X is time and Y is height. So this is part A. Part B, I got to take all this information and the graph and make a sinusoidal equation of it, sinusoidal function. Well, remember what I said? K, A, B, H. And then from there, we can write the equation. K is the midline. Looking at our graph, what's the midline? 18. A is the amplitude. The distance from the midline either to the max or to the min. Doesn't matter. It's the same. 16. Does anybody want to share another answer? 15. To find the value of B, we do 2 pi by the period. What's the period? 60. So it's 2 pi over 60. And we want to reduce that to pi over 30. Any shift? No shift, but no shift. But what do you notice about the graph? It's a flipped, which one, sine or cos? It's a flipped cos. Which means A not only is 15, but it's negative. Now we're ready to write the equation. Y equals A, which is 15, but I also need a negative in front of it, cos B, which is pi over 30, times X. There's no shift, so I don't put anything in parentheses. And then the midline, plus 18. But it's not quite complete yet. The numbers are all right. Yes, what should I write? Because we're in a problem-solving situation. H equals negative 15 cos pi over 30 t plus 18. That's our graph. Okay. Let's look at a couple other examples. And usually with these ones, you will be asked, you'll either be asked to sketch a graph of the situation or find the equation of the function of this situation. You normally won't be asked questions like B, but I'm going to do it anyway because you never know. Okay? So here we have, so when we see a question like this, I mean, I'm automatically setting up like this. 4, 1, 2, 3. Because it's not going to go below water. Unless, of course, it's a paddle wheel. Are you familiar with a paddle wheel? You know those things that it's like a boat on the water where there's a big sort of Ferris wheel-like looking thing on the back that propels it? That would go underwater. You've never seen a paddle wheel?
I've never been in a paddle. It needs to be in the paddle.
Gilly,
That's pretty.
Gilly, you always say that to me. It doesn't matter what I say. I could say bruz, I could say paddle. I've never heard anybody else. I've never heard anybody else say that. Okay? Watch this. 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 Look at this. Here, I'll even show you the paddle wheel queen that used to sail the Red River in Winnipeg. There you go. That is the paddle wheel queen. That used to be on the Red River.
I never said it wasn't a thing. I just
Okay. Let's see if I can find a, let's see if we can find the back of one. Let's see if we can find the back of one. There we go. There's a good picture. So there. And you can see that's how it moves. It's got like a Ferris wheel thing on the back. Anyway, notice that this one would go underneath the water. So that would actually go below the x-axis. Yes.
That means that somebody's paddling and those are moving.
No, chances are this is probably running on electricity.
Wow, that's very impressive.
Yeah, no, there's, yeah. You know what? They have to find eight guys. And their names have to begin with A, B, C, D, E, F, G, H.
That's more than
And those guys. Count again. And those guys spread out behind here. Those guys like, look, no, watch. Two go here. Two go here. Two go here and two go here. And then they're like this. And they've got little pedals. And they just go like crazy. Okay? This is all being recorded. Okay. Anyway, back to here. All right, so a pendulum bicycle has a maximum height of 30 centimeters above the ground, minimum height of 8. Out for a ride, a cyclist pedals at a constant rate of 20 cycles per minute. What's this? What is the x-axis? Time. In what?
Yeah.
You sure? I would suggest we maybe do it per second. And I'll show you why. That'll be clear in a second. And then this will be height of the pedal, which is in centimeters. Okay? All right, so let's get these values. Well, what's this one? 30. Because that it tells you that's the maximum height of the pedal. It also tells you the minimum height. 8. Which means we can find the mid height.
11. 22.
Anybody else want to take a? Yes, you were so.
19.
19. Now, this is where we got to be careful because we can't say one. Okay, we decided to go seconds. We can't say 60 because it doesn't complete one cycle in 60 seconds. It completes 20 cycles. So we need to figure out if it completes 20 cycles in 60 seconds, how long does it take to complete one? 20 cycles in 60 seconds is
One cycle.
one cycle
And 3.
in.
3.
How did you get 3? You're right. How did you get it? 60 divided by 20. therefore, this is 3. Okay, now we've got everything we need. Remember, we're just sketching the graph right now. We're not doing the equation just yet. Okay, so where should I start?
At 8.
Yeah? Is that how you normally start pedaling? At the bottom? Or do you need to get up top so you can get to the next bottom?
Well, you could start going from the bottom though.
You'd have to swing, but you wouldn't be going anywhere. You'd have to swing it around to get to the top. That's why you can't move. You're having a rough day. Start at the top. Just accept it. Just accept it. Just accept it. Anyway. So first notch on the t-axis, we're halfway down. Then we get to the minimum. Then we're back to halfway up at the third notch. And then we've completed a cycle after 3 seconds. Okay. So that's what this one looks like.
Is there no arrows?
Oh, you can have an arrow on the right, sure. But not on the left. Okay, so let's get the equation. K, A, B, H. There's no shift. There's no horizontal shift. Midline? 19. Amplitude? Well, just find the difference between here or the difference between here. 11. B is 2 pi divided by the period. And because we went in seconds, the period is 3, so it's 2 pi over 3. Is it a normal sine or cos or a flip sine or cos? Normal cos, right? It's a normal cos. So I'll just put normal cos. So I don't have to add anything. So my equation is going to be, remember, instead of y, I'm going to put h. Then what? Sorry? 11 cos 2 pi over 3 t. Yeah, you can put parentheses. You don't need them, but you can put plus 19. Good. So that answers A. For B, so this is A. For B, we have to find the height of the bicycle after 2 seconds. Or sorry, the height of the pedal after 2 seconds. So I got to plug 2 in here. And guess what? We're going to do this without a calculator. First thing I need to do is multiply these 2. What is 2 pi over 3 times 2? Or 2 over 1? 4 pi over 3. The next thing to do is to take the cos of 4 pi over 3. You know how to do that exactly. What is the cos of 4 pi over 3 according to the unit circle? -1/2. Now, here, we might want to go to decimal. What's half of 11? 5.5. So negative a half of 11 would be negative 5.5. And what's negative 5.5 plus 19?
13%.
Positive 13.5. So that means we're there. That's it. Okay. Like I said, this kind of question is very rare, but I did want to show it to you just in case. Okay, let's look at the last one. Here's another example of something that occurs in cycles, is tides. Okay. Now, notice you are asked to write the function. You don't necessarily need to graph it. If you feel comfortable using all the information in the question to get your values of K, A, B, and H, go ahead. But I always like to sketch the graph because I find it a lot easier to get the equation from a graph than just from a bunch of words that have numbers in them. 3 notches there for min, mid, and max. 4 notches along here, and this is time, and this time we're in hours. And we're in height again, the height of the water. Okay, so now I can start filling in my numbers. So the tide in Victoria reached a maximum height of 3 meters at 2 p.m., minimum height of 0.2 meters at 8 p.m. The tide completes 1 cycle every 12 hours. Write a sinusoidal function, either sine or cosine, that relates the height of the water to the time. Let's assume that a cycle begins when the water is at high tide. So we're going to begin here. What are my 3 values? Where does 3 go? 3 is at the top. 0.2 is at the bottom. And then 3 plus 0.2 divided 2 will be in the middle. 3.2 divided 2. What's my 4th notch? 12. Because it completes a cycle. Remember, time is in hours here. Completes a cycle after 12. We start at high tide. So we go down to the midline. Down to the midline. Then to the minimum. Back to the midline. Up to the maximum. And our cycle is completed. And we've got a normal coast. So K, A, B, H, no shift, normal coast, not a flip one. K is 1.6, A is, sorry, 1.4. B is 2 pi divided by 12, which is the same as pi over 6. Put those into your function and we're done. So remember, instead of y, we're dealing with h equals a 1.4 cos, then b, which is pi over 6, times x, but in this case it's t. No, nothing in parentheses because there's no shift, and then just plus the k value. And that's it. Okay. I like these ones.
back